Good morning to all of you. In this video capsule, we shall see a bird's eye view of the DC-DC converter system. Consider a load such as this. This load is supposed to get only a DC voltage. The DC voltage can be given by a DC source such as this. The DC source that we have used is a battery. However, the battery and the load may be incompatible. For example, the battery may be a 12 volt battery, a 24 volt battery, or a 48 volt battery, and the load may be a 5 volt load. In such a case, the battery cannot be directly connected to the load which expects a 5 volt. We need to have a power interface in between called a DC-DC converter. And this is the focus of our topic, and this is what we are supposed to do and design. However, in most cases, the input may not be a battery. The input may be the AC grid itself. If it is the AC grid, then the input wave shape will be an alternating bidirectional voltage wave shape, 230 volts RMS. Now this is not directly compatible to the DC-DC converter input. Therefore, we need to do a further power conversion for this particular wave shape. That is, we rectify it using a rectifier and make the wave shape into a unidirectional wave shape. This unidirectional wave shape is highly varying, and this is still further not compatible directly to be given to the input of the DC-DC converter. So we use another interface called the filter. The job of the filter is to transform this highly varying unidirectional voltage into a low ripple unregulated voltage. This low ripple unregulated voltage is fed to the input of the DC-DC converter. This gets transformed into a high quality DC output which can be fed to the particular application or the load which expects a pure DC. If you look at the rectifier is nothing but a simple diode. It may be a half bridge rectifier or a full bridge rectifier, but we shall discuss the most popular rectifier which is used in most of the products today, which is the full bridge rectifier. This will be followed by a filter which could be LC filter, that is an inductor capacitor filter, or just a C filter. Here again we shall discuss the C filter, which is the one which is most widely used in most of the products. In the case of the DC-DC converters, the main components in it are the MOSFET or IGBT, some power semiconductor switch, there will be capacitors, and there will be inductors. So all these major components will be put together in specific topologies to achieve specific outputs, which we will discuss later on in this course. The objective of this particular course is the DC-DC converter design. However, in the initial stages, in the initial classes, we shall discuss the rectifier and filter, because we need to obtain a DC output at this point such that it can be fed to the input of the DC-DC converter from the source, the wall outlet source, which is a 230 volt AC voltage. So the initial discussion this week will focus on the rectifier and filter design.